Konnichiwa, Paris. Bonjour, Paris. Good morning, Paris. It's a great pleasure for me to present today Kuraray company, a company born in Japan. Today, I would like, together with my colleague, talk to you about the superior performance in demanding applications of Kuraray's unique polyamide PA9T. Before we start, let me briefly introduce ourselves. My colleague, Dr. Amir BAHRAMI, is responsible for the technical development, and he's a technical expert for our PA9T material. Myself, I'm located in Frankfurt, whereas Amir is located in Antwerp. I'm responsible for new business development for Kuraray here in Europe. Let me just quickly share our agenda with you. I will give you a little introduction to Kuraray company, as I'm not sure you're very much familiar with this Japan-based company, which already has a global footprint anyway. After that, Amir will talk to you about GenestarTM, our proprietary PA9T polyamide. He will discuss some product features and give you some application examples. After that, we will change the topic, and I'm delighted to talk to you today about another Kuraray product, Movital Thin Film PVB or polyvinyl butyrol, a remarkable material also be suitable for composite applications. So let's go and get started. Kuraray, what's our mission? Why are we doing the work we're doing? Well, we try to make life on Earth better through having technologies and products which make life easier for people and certainly also for the environment. And this is our mission, why we're here today, to show you some of our remarkable products able to make life easier and protecting environment. Kuraray itself is a company founded nearly 100 years ago in the western Japanese city of Kurashiki. It's halfway between Osaka and Hiroshima on the main island, Honshu Island. Founded in 1926, we are now employing about 11,000 plus people globally. Since 1991, Kuraray has a presence in Europe, and they started in Düsseldorf in Germany. Today in Europe, we have about 1,000 employees working on different sites throughout Europe. The company's size in terms of global turnover is about 4.8 billion euros, and sales in Europe account for about 1.1 billion annually. As a specialty chemicals company, we are investing 3.7% roughly per year in R&D. So you can see there is a strong focus on R&D in Kuraray company. As I already mentioned, Kuraray has now what we call a global presence, and we have locations in 38 countries all over the world. I hope you can see the slide good. Yeah, because on my screen it's not really sharp. You see the different places and locations where Kuraray is already present, ranging from Australia up to Southern America, and the only white spot, but we work on it, is currently Africa. We have technical sites, we have production sites, we have sales offices, so all spread around, and the star marking our headquarters in Tokyo in Japan. Kuraray has a big number of different products for various applications, and I would like to take this opportunity to very briefly introduce to some of them. Next to a fiber business, Kuraray was founded actually as a fiber producing company in 1926. We have now expanded a lot. So we have a main chemistry, which is vinyl acetate-based chemistry. We have chemistry based on isoprene chemistry, which is also a big pillar in our business today. And we are having activated carbon business, yet the third big pillar in the company. And with that, we are serving a wide range of applications, may it be for laundry care, for single-serve packages for your washing. We are doing cleaning of wastewater from wastewater tanks on boats. You can also find purification using hollow membranes made by Kuraray, and a big number as well. But the most important one I think I would like to mention, it's shown on the left-hand corner downstairs, is a polarizing film made out of extruded high-quality polyvinyl alcohol used in TFT screens. And this is really a remarkable and a very strong product and position for Kuraray. Okay, talking about Kuraray, we would now focus on the proprietary high-performance polyamide material. And with that, I would hand over the word to my colleague, Amir.
Thank you, Robert. So first of all, good morning. Thank you everyone for being present. It's a pleasure to have you all here. So I will explain to you, as Robert mentioned, our polyamide business. So let's first of all see what is GenestarTM PA9T. So PA9T, as you see the structure here, it's a polyphthalamide or an aromatic polyamide. So it's a long chain polyphthalamide, and we produce it mainly in two categories. So the extrusion grades, which have a slightly lower melt temperature at 264 degrees C, and the injection molding grades that have a higher melting temperature at 300 degrees C. Both injection and extrusion grades of GenestarTM PA9T have a high glass transition temperature of 125 degrees C. So you will see in the course of my presentation that this unique structure, so the long diamine chain and the terephthalic acid, is the one that gives the specific features of PA9T to it, which are, first of all, high temperature performance, mainly derived from high glass transition temperature and also a high degree of crystallinity. PA9T is the lowest water absorbing high temperature polyamide, again because it has a long hydrophobic diamine chain. It is compatible to high voltages because of a high comparative tracking index, a high CTI, and also it's chemically very resistant. It has a good chemical and hydrolysis resistance. GenestarTM PA9T is polymerized in solid state, so it is a very pure resin which results in low ion and oligomer extraction, and finally it can be laser welded because of a good laser transparency. So let's see with these features how PA9T can be used in composites business. We will have a look at potential applications, the semi-finished composite products based on PA9T, and finally some examples of parts. With the features that you saw for a high temperature polyphthalamide, typically PA9T can be used in relatively large particles, large parts, my apologies, which need good dimensional stability, and the parts that are exposed to high heat and or corrosive environment, salts. So this could be, for example of a roof cross member, a bumper beam, or parts in aerospace like rotor blades, wings, and flaps. These are the example applications that are developed for Kuraray with the help of our partner Forward Engineering. Likewise, for examples in battery casing, where you need good mechanical properties, impact resistance, high temperature performance, and also, again, low moisture influence for the sake of dimensional stability and chemical resistance. And the last example of potential applications would be in a hydrogen storage pressure vessel because of the need for good mechanical properties, fire resistance, good chemical resistance, and also the point that I did not mention as features of PA9T, also good barrier properties. So PA9T inherently has good barrier properties to different media, to fuels, to gases, and it is used in other applications, among other applications also in fuel lines. So with this example of potential applications, let's have a look at semi-finished products. We have different semi-finished products based on PA9T matrix, like different semi-preg, pre-pregs, glass fiber reinforced, glass fiber and carbon fiber UD tapes in different dimensions and sizes, which then we can use to make parts like those shown on the right side, a pressure vessel or automotive structural parts. And by the way, these part examples are shown on our booth, so in case you're interested, please don't hesitate to drop by and have a look at them. So here I'm showing just briefly the point that we produce, for example, glass fiber organo sheet using PA9T matrix, and this is done by our partner Neue Materialien Fuss, Neuma Fuss in Germany, and then it's thermoformed and back molded again using PA9T. So you can have the same resin for the matrix of your composite and for the back molding or other injection molding related applications to make something like this door crossbeam for automotive applications. Or as you see in this video, which is done at our partner Fraunhofer Institute, IPT in Aachen, Germany. This is laser-assisted tape laying and consolidation, where a PA9T carbon fiber UD tape is being wound around a typical PA6 liner to make a pressure vessel. So I hope I gave you some taste of how GenestarTM PA9T is used, can be used for different composite applications. And please don't hesitate to drop by our booths if you're interested to know more about the resin itself or the parts and applications that we have. And I appreciate your attention. So I hand over again to Robert for continuing.
Thanks very much, Amir.
No problem.
Dropping by in our booth, as Amir just said, it's here in Hall 6 in aisle F65. So just in case you want to drop by, that's the location you can find us. Now to something completely different. Yet another high-performance polymer from Kuraray. It's called Movital. Movital is chemically a polyvinyl butyrol, and it looks like this. So for the chemists among you may recognize three distinct features, and they are shown here. That's the acetate group. It's a hydroxyl group shown here in yellow, and in purple and orange you find the cyclic acetyl group. This is the characteristics for this type of polymer, where you have three groups to play with, in addition to the molecular weight, so the length of the chain. And this gives rise to very different properties, from low viscous material to very high viscous material. For material you can dissolve easily in solvents like ethanol, into material you simply just do extrusion forming films. And that's what we're talking about today, about a film which is remarkable as it's a pure material, and it's going to be in thicknesses of 50 to 200 micron thicknesses. This material is very well suited also for thermosetting application. If you can see here, we have a very good enhanced shelf lifetime for that material, because you can produce it, extrude it as we deliver it, and you may use it at any time without any special requirements coming to storage. It's a solvent-free application, so you can get the material as delivered and can use it straight away. It is odor-free and non-toxic, which is very important, because it only consists of three elements. It's hydrogen, oxygen, and carbon, of course. You can control the delamination for enhanced energy absorption, and that's something I just like to inform you about. One of the major applications for PVB films is in the glazing industry as protective glazing. So anything like glazing you walk on, overhead glazing, you will find the product, in addition to automotive, where this is part of your front screen of the car, where on impact you will have a breakage of the glass that takes some energy away, but you also will have a controlled delamination, and that absorbs a lot of energy. So it's very important for the material to be there, strongly bonded, but not too strong, in order to absorb energy in case of emergency. And this is the same process and the same feature you may be able to apply when using thermosetting resins, having different layer, where the PVB layer, the thin PVB, may be just adhered to the material but not penetrating it, not consolidating in it. That will give a very different feature in performance if you have the material not penetrating into your matrix material, but being strongly bonded, but yet able to be released, and that absorbing material. So that's, for example, important for protective clothing, to have clothing which is bulletproof. So this is the delamination, taking away the energy out of the system and protecting the persons. Of course, it also has excellent, due to the chemical structure, excellent adhesion to aramid, glass, carbon, and other polar materials. Having said that, you can also expand this to other applications where you find it on wood or metals or other surfaces where you may want to adhere it. The process conditions for Movital film is just an example. You can make this textile plus PVB thin film material, expose it to some elevated temperatures for some 5 to 10 minutes at 5 bar pressure and roughly about 150 Celsius plus minus, and then you produce an excellent composite material. Again, we do not want the material to penetrate in order to have this very good release and energy absorbing properties. The major benefit is really, as I just said, that it's not deeply integrating. After end of life, and we give you here an example, we take the substrates away. In this case, very often it's glass, because that's one of the main applications. The first part, of course, you can go as an option to incinerate it, so just burn off the PVB material, the interlayer. As I said, it's only consisting of hydrogen, carbon, and oxygen. You can only produce non-toxic byproducts, which is basically water and carbon dioxide. So that's all. So this is very environmentally safe and friendly. However, it's a bit smarter to reuse the material, and this is again a very remarkable property of PVB. You can dissolve it in organic solvents, for example, in bioethanol. Bioethanol is certainly a well-known product, and with that you can dissolve the PVB into this alcoholic solution, and the alcoholic solution you can purify, you can retrieve the PVB material and can reuse it again. So that's a very good way to get a circular usage of your PVB material. And in addition, of course, the other substrate, in this case glass, is remaining untouched because the solvent process usually does not harm your substrate material there, and you can also reuse it for a second, third, or extra lifetime. Next to this application I just showed for that, we would like to inform you about other potential uses of the PVB material. It is used these days in batteries already for the electric vehicles. It's a varnish for top coat surface treatment of, for example, cars, especially repair lacquers. Lightweight parts, as we said, if you use it as a composite material, can be made out of PVB, thin film, and the coatings anyway. Interior film or material can also be used for interior setup in the car using this material as a binding material. Yeah, and with that, we conclude our short presentation about Kuraray and two of their remarkable products. And as we still have, my clock shows it here to me, have some time, we are ready to take your questions. Thank you very much for your kind attention. Much appreciated.
Thank you. No question.
There are two ladies waiting for the microphone to be passed on, so don't be shy. Okay. If there's no further question, again, thank you very much for being here today, and enjoy the rest of your show. Thank you very much.
Thank you.
Bye-bye.
Bye-bye.